To Cambridge Chemistry channel with Sarvat Ahmed. Be sure to like the video and subscribe the channel. Really helps the channel to grow. In this video I will continue the introduction to AS level organic chemistry past paper or topical past paper. So let's start. Question number 785 9701 May June 20, question paper 13, question 30. Compound X has a structure shown. Which type of carbonyl group is present and how many chiral centers are there in one molecule of X? So ketone is present in this compound and one chiral carbon is there. For example, this carbon is chiral carbon because it is surrounded by hydrogen, and this is CH2, this is CH3CO, and this is CH. So this is chiral carbon. Only one carbon is chiral carbon in this compound because this carbon is surrounded by 4 different groups. So this is not CH2, this is CH. So D option is correct option. Ketone, carbonyl group ketone, and chiral center is 1. Structural and stereoisomerism should be considered when answering this question. Compound X, Y and Z are shown. How many other isomers of C3H7ClO are there that are alcohols? So these are X, Y. How many other isomers? So this is one isomer, 2-chloro, 2-chloro, propane, 1-ol. This is 2-chloro, propane, 2-ol. And this is CH2, this is ether, methoxy, chloroethane. So this is also different, and this is 3-chloro, propane, 1-ol. This is also different, 1-ol. And this is 1-chloro, this is 1-chloro, propane, 2-ol. So 5 different other isomers are formed with these compounds. Next question is unsaturated hydrocarbon octa 1357 tetraene can display geometric isomers. How many isomers exist? So 1 octa, this is one is this type cis cis, This is cis and cis isomer. This is trans and cis. So this is trans, this is and trans and cis isomer. CHHH on this side, so this is trans and cis, and this is trans. Hydrogen on this side, and this group on opposite side. So this is trans, and this is ethyl alkene group on this side and hydrogen on this side. So this is trans. So one is cis, other is trans cis, and this is trans isomer. Next question: how many structural isomers are there of trichloropropane? So this is how to draw trichloro. 1 2 3 trichloropropane, and this is 2 2 3. 2 number 1 number 2 has 2 chlorine atom, and number 3 has also 1 chlorine atom. So 2 2 3 trichloropropane. This is 1 1 2 2 chlorine on carbon number 1 and 1 chlorine on carbon number 2. So this is 1 1 2 trichloropropane. And number 4 is this 1 1 trichloro. This is 1 1 trichloropropane, and this is 1 1 3. This is also different isomers. So I have 5 isomers of this compound. The diagram shows 2 different compounds. The total number, what is the total number of structural isomers including compound 2 that could be formed by adding a second methyl group to the ring of compound 1? The number of pi electrons in each compound. Number of pi electrons: 1 and 2, 3 and 4, 1 and 2 electron, and 1 and 2 electron. So 4 electrons and 4 electrons. So number of isomers: so by changing the methyl group, so we have 5 isomers of this type, like this. Look at here. If we draw like this, CH3, this is 1, so this is another methyl group. like this. And now this is another isomer. CH3, CH3, and this. So this is another CH3, CH3, and this is another. So 4, and including this is 5 number of isomers. Next question, which compound is chiral? This is A option. This is one option. One chloro, 3-methyl butane. 1, 2, 3, 4. Which compound is chiral? This is not chiral because this carbon is not chiral, because on this side CH2 is there and on this side CH2 there, so that's why A is not chiral. So this is B compound, CH3, 2 chloro, this is 2 chloro, this is 2 chloro and 2 methyl butane. So this is different group, this is different groups, this is different group, but these two are same group. So this is not chiral. C option is correct option, because 2 chloro, this is 2 chloro, this is 2 chloro, and 3 methyl, this is 3 methyl, 2 chloro, 3 methyl. So this could be chiral because this carbon is surrounded by 4 different groups. One is chlorine, other is hydrogen, and third is methyl, and second is this whole group. So that's why C option is correct option. This is 3 chloro pentane, 1, 2, 3, 4, 5 pentane. On this side C2H5, on this side C2H5, two same groups are on this carbon, so that's why this is not chiral. So C is chiral carbon. Compound X does not show cis trans isomerism. What could be the identity of compound X? Compound X does not show cis trans isomerism. 1,1,2 trichloropropane. 1,1,2. 1,1,2. This is propene. Double bond. This is not chiral. Cis trans. Sorry, this is not cis trans because this carbon has two. This double bonded carbon has two same groups. So that's why this is might be correct. Now let's check the other options. This is the B. So this is chiral carbon. Sorry, this, there is a double bond in between these two carbon. This is surrounded by H and Cl, and one this is chiral carbon because sorry, cis trans, because two different groups are, one is this and other is this. Look at here, we can write like this. two different groups are present. So this is cis trans can be. So this is wrong option. So C is 1-chloro-but-1-ene. So this is C option, 1-chloro. This is 1-chloro-but-1-ene. This is also again cis trans geometrical isomerism, because this double bonded carbon has two different groups, and this double bonded also has two different groups. So this is also chiral. So this is also incorrect. 1-chloro-but-2-ene. CH3 Cl CH2 and H. This is also cis trans. So this is also incorrect option. So A is correct option. Next question is, fructose is a sugar with more than one chiral centers. The fructose molecule is shown with X, Y and Z, indicating 3 carbon atoms. Which carbon atoms are chiral carbon atoms? So X and Y are chiral carbon. This is not chiral, because this carbon is surrounded by 2 hydrogen atoms, 2 same groups. These are 2 same groups. So that's why this is not chiral. This is now look at X and Y. This carbon is surrounded by H, and this is on this side OH, and on this side this is whole group. This is also chiral carbon, because this is a different group, this is also different, and this is also different group. So that's why this is also X and Y are chiral. Next question is, molecule G is shown. How many chiral centers are present in each molecule of G? So there are 3 chiral carbon. Look at this. This is C, H, CH3, CH2. This is whole this group, and this is also different group. So this is chiral. So now next is also this carbon is chiral. This carbon is chiral because H, this is surrounded by this group, and on this side this group, different group, and on this side different group. So this is also chiral. So this carbon is also chiral. Now next, third is, this is chiral. Now this is not chiral because CH3 and CH3 same group, these are the same group, so this is not chiral. So look at this carbon atom. C, CH2, and this is whole group, H, and carbon. This is also this group. So this is this carbon is chiral carbon, not this carbon. So 3 are chiral carbon. Considering only structural isomers, which is number of alcohols of each type with the formula C5H12O, primary, secondary, tertiary. How many primary, how many secondary, and how many tertiary? So this is primary alcohol. This one is secondary alcohol. This is also secondary alcohol. This is also secondary alcohol. This is primary alcohol, and this is also secondary alcohol. Sorry, this is also primary alcohol. This is also primary alcohol, and this is 1 2 3 4. This is tertiary alcohol. This is alkyl group, this is alkyl, and this is tertiary alcohol, and carbon has no hydrogen atom. This is tertiary. So how many primary and how many secondary and how many tertiary? 1 2 3 4 are primary and 3 are secondary. This is secondary, this is again secondary, and this is again secondary. This 1 2 and 3. So 3 are secondary and 1 is tertiary alcohol. So next question is X has a molecular formula C5H12O. X has a branched carbon skeleton and a secondary alcohol functional group. How many structural isomers fit this description of X? C5H12O has a branched carbon skeleton and a secondary alcohol. How many structural? Only structural. So this is the only option. This is the only option of the structural isomers. CH3 2-methyl butane 1-ol, and if we place over here this is again 2-methyl propane 2-ol. The only option is this, because if we place CH3 over here, this could be the tertiary alcohol. For example, look at this: CH3, CH, CH3, and OH, and CH3. This could be the now tertiary alcohol. So in exam, this is the condition that a secondary alcohol, so only one isomer is possible, so that's why it is incorrect. Next question is, a new jet fuel has been produced that is a mixture of different structural isomers of compound Q. So which skeletal formula represents a structural isomer of Q? Look at here. First count the number of carbon atom. So here in this case, number of carbon atom is 14, and this is Q. This is Q. It has 14 carbon atom, and now this is 12 carbon atom, so that's why it is incorrect. This is 13 carbon atom, it is incorrect, and this is 14 carbon, this must be correct. And this is also 1 2 3 4 1 1 2 3, and these two structures 1 2 3 4 5 6 7 8 9 10 11 12 13 and 14, but this is the same structure as drawn above, so that's why this could not be isomer. So this is the isomer structure. C has 14 carbon and it is different structure. Look at here. This is different from this carbon atom. This could be different. If you count from here, 1 2 3 4 5 6 7 8. So this is the long chain. 7 8. This is the long chain. So this the name of this compound is eight and 9. So this is 1 3 5 7 7 7 and 8. 1 2 3 4 5 pentamethyl nonane. And if we count name of this compound, 1 2 3 4 5 6 and 7. 5 6 6 and 7. Yeah, 5 6 and 7. 1 2 3. So here are more branches. So this is the number we're starting from here. 2 3 1 2 2 3 4. So this is different. 2 3 4 6 5 isopropyl. 2 3 4 6 2 3 4 6 tetra methyl on 6 5 is isopropyl. So this is different, so this is the best option. So this is, now let's count this carbon atom. So this is the same. 1 2 3 4 5 6 7 8 9. 2 3 5 7 8. This is same. 2 3 5 7 8 pentamethyl. So this is the same. This is same structure as the Q, so that's why it is incorrect. So these A and B has 13 carbon, so that's why number of carbon atom is not matched with this Q structure. So that's why these A and B are incorrect and D are incorrect, because this is the same structure as in Q. So C option is correct option. Next question, there are 3 structural isomers with the formula C5H12. Which formula correctly represent these 3 structural isomers? So these are 5 carbon. Number of isomer, no isomer, so this is not isomer. 1 2 3 4 and 5, 1 2 3 4 5, 1 2 3 4 5. So this is isomer, this is the different structure, this is also different structure. So number B option has, look at here, if we look, this is CH3 CH2 CH3 and CH3. So this is the same structure as like this, CH3 CH. So that is the same structure, CH3. So this is the same, so not isomer. And this over here 4 carbon, 5 carbon and 5 carbon. So this is not the isomer of these two. And this is 1 2 3 4 and 5, but this is the same structure. These two are same structure because this is on number 2 methyl group, this is also number 2 methyl group. So that's why this is incorrect. These two structures are same because at 2 position methyl group and over here at 2 position methyl group. So these are two same, so that's why this is also incorrect. These three are different structure. Look at here, CH3, this is straight and this is branched, CH3 CH2 and CH3, and this structure is like CH3 CH3 CH3. This is isopentane, so this is also different structure. So so A option is correct option. Structural isomerism and stereoisomers should be considered when answering this question. How many isomers with the C4H8 have structures that contain a pi bond? This is one isomer, this is second 2, this is 1 butene, this is 2 methyl but 1 in prop 1 in, this is 2 butene, 1 butene but 1 in, this is butane 1 in, this is 2 methyl prop 1 in, and this is but 2 in, and but 2 in has two structures, cis but 2 in and trans but 2 in, so that's why it has two structures, so 4 isomers are possible. Kerosene is used as an aircraft fuel. Q is one of the molecules in kerosene and has the skeletal formula shown. This is the skeletal formula shown. This is 10 carbon over here, 1 2 3 4 1 2 3 4 5 6 7 8 9 10. In this compound 9 carbon, so this is not could not be isomer. This has 8 carbon, so this could not be isomer. So this has 11 carbon, so this could not be isomer. This has D and this is different structure from this structure, so that's why this is 3-ethyl 2-methyl haptane and this is 2,3,4 trimethyl haptane structure. So and it has similar molecular formula and different structure formula, so this is the D is the best option. Question number next question is the drug cortisone has the formula shown. So in addition to these chiral centers marked by this stars, how many other chiral centers are present in the cortisone molecule? So this is 3 shown and other 3 is this chiral carbon. This could be chiral carbon because this is CH3, this is CH and this is CH2 and this is also 1 2 3, this is whole structure and this is also carbon atom 4, so this is also different, so this could be chiral. this is chiral, and this is also chiral because this carbon, this is carbon, this is CH3, this is again different group, this is also different group, CH2, and this is also different group, and this is also different group. So that's why this could be chiral. So again this is also chiral carbon, and this carbon could be chiral because 4 different groups. This is C, this is OH, and this is CH2, and this is C. So this is also chiral carbon. This is CH3. See, there is different group. So this is also different group. This is also different group. So 3 isomers are possible. Geranyl and linalool are compounds found in same flower fragrance. Which statement is correct? They are chain isomers of each other? No, they are not chain isomers of each other. Which statement is correct? They are chain isomers of each other. They are geometrical isomers. No, not geometrical, because this carbon, double bonded carbon has same, this double bonded has same group. So they are optical isomers of each other. No, this is not optical isomers of each other. Same structure, so they are positional isomers of each other. Yes, this is positional isomers because in over here double bond at 2 carbon atom, this is 1, this is 2, but over here double bond is present at 1 carbon atom. So this is positional isomers. Structural isomerism and stereoisomerism should be considered when answering this question. Which formula identifies a single substance? Which formula identifies a single substance? Cl, 2 Cl over here and 1 Cl over here, and number 1 CH3 CH Cl CH2 H. This could not be single substance, so that's why it is incorrect. CH3 CH double bond CH3. This is also cis trans isomers over here, and this is chiral carbon. It has 2 substances and it is not it has cis trans, so this is also incorrect. This compound has single substance because not chiral, not cis trans, so that's why this is only a single substance. So this is correct. C4H10 can be of different there is also a different possibilities. More than 2 structural isomerism can be possible with this compound C4H10. Like look at here, CH3 CH2 CH2 CH3. Another structure is CH3 CH3 and CH3. So there are also 2 possibilities are there, so that's why C option is correct option. So next question, structural isomerism and stereoisomers should be considered when answering this question. If a molecule contains two non-identical chiral carbon atoms, four optical isomers exist. Non-identical carbon atoms. How many isomers are there with C17, H14O and 5-membered ring? These are the conditions. 5-membered ring, tertiary alcohol group should is there. So look at here. One, two, three, four, five, 6 and 7. Tertiary alcohol group could be possible. Sorry, this is not the straight chain isomer. So he asked that there should be 5-membered ring. So look, this is carbon, this is carbon, this is carbon, and this is 5-member, and over here one CH3 and OH. This is tertiary alcohol. This is CH2, 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 and this is chiral carbon. So this is chiral carbon, and this is again CH3, and this carbon has one hydrogen atom. This is also chiral carbon. So there are 4 possibilities of there. So for this chiral carbon there is this, because this is optical, 2 structures are possible, and with this chiral carbon also 2 structures are possible. So that's why total 4 molecules, 4 structures exhibit this compound. So there is, let's see other, C H H. So we have to draw pentagon, 5-membered ring carbon. So this is CH3, over here OH, and this carbon now CH3 and H. This is CH2, this is CH2. So we have again 2 chiral carbon. One is this, one is this, and 2 structure are possible with this chiral carbon. This is another chiral carbon. So 2 structures are possible with this carbon. So total 4 isomers can be formed from this structure. And there is another isomer, five carbon. No, CH2, CH3. Now this is CH2, 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 CH2. So this is not chiral carbon. This carbon is not chiral carbon, because on this side CH2, on this side CH2. So that's why the all structure on both sides are same. So that's why this is not chiral. So one isomer is this. So total isomers are 9 isomers for this compound. Structural formula of compound Q is shown. How many stereoisomers exist with this structure? So there are four two double bonds over here, two double bond over here. Look at here, two double bond. So this is 1 2 3 and H, and this is different. This is 1 2 3 and 4. This is also different. The two isomers are possible for this side, and there is another two cis trans. One is cis, another is trans. So two possibilities, and two possibilities over here. Carbon 1 2 3. They were over here CH3. This is CH 1 2 3, and this is also a different. This double bonded also has two different atoms, and this molecules are group of atoms, so this is also different. So two possibilities over here. So total four isomers are formed. Which compound does not exhibit stereoisomers? This question is repeated. I have discussed earlier, so C option is correct option. C has only one structural possibility is there. Geraniol and nerol are compounds found in sunflower fragrances. They are isomers of each other. Which type of isomerism is shown here? Chain isomers. No, this is not chain isomers. These are exhibit geometrical isomers. Both exhibit geometrical isomers because this is different group. These two are different, and these two are different. ACH2. This is different too, but these are same. So these cis trans, and over here same structure, and same structure over here. This is different, and this is different group. So that's why cis trans geometrical isomerism. B option is correct. The diagram shows two different compounds. The total number of structural isomers including compounds 2 that could be formed by adding second methyl group. So I have explained. This is also repeat question, so I have discussed earlier. 5 number of isomers and 4 pi electrons. In 1865, Kekulé suggested a ring structure for benzene in which a hydrogen atom is attached to each carbon atom. In this structure, all of the bonds remain in the places shown. Assuming this is the structure of benzene, how many isomers of dichlorobenzene is possible? Dichlorobenzene is possible. This is 1,2 dichlorobenzene. This is same structure because, or if we draw like this, so these two are same because this is again 1 2. We count number of carbon atoms from here to here, and in this case 1 to 2. So these are same structure. So this is different 1 and 3. This is 1 and this is number 3 carbon atom has chlorine. 1,3 dichlorobenzene, and this is 1,4. So these structures are possible. 4 structures are possible. 1 2 1 3 and 1 4, not 4 3 only. This is 1 2 dichloro, and this is 1 3. This is also 1 2 1 2 on this side. This is 1 3, and this is 1 4. 3 isomers are possible. The diagram shows the structure of vitamin A. How many chiral centers are present in one vitamin A molecule? One chiral center is there. So this is look at here. This is only one chiral center. No, this is not chiral center, 0. This is same groups over here, and this is not because double bond is here. So this is not double bond is here, and this is not double bond is here. So this is also not possible. CH2. So 0 chiral centers are there. Which statement about stereoisomers is correct? Cis-trans isomers are mirror images of each other is correct. Cis-trans is not mirror image. Optical isomers must contain a double bond. No, optical isomer has chiral carbon atom which is surrounded by 4 different groups. This is incorrect. Uh, Stereoisomers have the same structural formula as it is. Yes, this is correct of statement because stereoisomers have same structural and same molecular formula, but the arrangement of atoms in space is different, so that's why it is correct. Must contain a chiral stereoisomers. So there are two types of stereoisomers, cis-trans and geometrical. Cis-trans and optical. So must contain a chiral center. So this is not correct. Some vegetable oil contain trans fat that are associated with undesirable increases in the amount of cholesterol in the blood. In these oils, the word trans describes in the usual way the arrangement of groups or carbon to carbon double bond. In the diagram below, R1 and R2 are different unbranched hydrocarbon chain. Which diagram correctly shows an optically active trans fat? This is R1 and this is R1. These two are same groups, and this is hydrogen and this is hydrogen. So these are present on this side, this side. So that's why this is trans isomer, trans fat. R1, R1. This is R1 and this is R2. So these are two different groups. Okay, these are two different groups. So that's why this is trans. This option is correct. This is cis. This is cis. So that's why it is incorrect. This is again cis. So that's why it is incorrect. In 1869, Ladenburg suggested a structure for benzene 3686 in which one hydrogen atom is attached to each carbon atom. This is Ladenburg structure. A compound C6H4Cl2 could be formed with the same carbon skeleton as a Ladenburg structure. How many structural isomers would this compound have? So this is CCl, this is one isomer, this is second isomer, and this is third isomer. 1, 2, 2, 3. And this is 1, 2, 3. This is 2, 3. Yes, see on this side, Cl. This is on this side. So this is the two different structures. 1, 2, and this is again two different. Another CCl placed over here and other CCl is placed over here. So 3 isomers are possible. The compounds aspartame is widely used as sweetener in diet soft drinks. Aspartame, aspartame is chiral. There are no chiral carbon atoms in C6H5. How many chiral carbon atoms are present in molecule of aspartame? So two chiral carbon are there. So this is one, different structure, and H is there. Four different structures, four different group of atoms are and this is also surrounded by four different NH, CH2 and C. So and one is hydrogen. So two isomers are possible. How many isomeric esters have the molecular formula C4H8O2? So this is four isomeric structure. One is this ester, other is this ester. This is propyl methanoate. This is ethyl ethanoate. This is ethyl ethanoate. This is propyl methanoate, and this is isopropyl methanoate. When two alkyl groups are attached, methyl groups are attached with one this carbon atom, this is known as isopropyl methanoate, and this is methyl propanoate. So four isomers are there. Sorbitol is a naturally occurring compound with a sweet taste. It is often used as a substitute for sucrose by the food industry. How many chiral centers are there? No chiral centers. This carbon is no chiral. This carbon is surrounded by this group, this and this. So this is also chiral carbon because surrounded by four different groups. Also chiral carbon surrounded by four different groups. This group, and this group, and this is also four different groups surrounded by four different groups. B option is correct option. This compound shows the optical isomerism. 2-chloropropane. This is 2-chloropropane, not optical isomer. This is 1,2. This is optical isomer because this carbon is surrounded by four different groups: CH3, Cl8 and CH2Cl. This is correct option. And C, look at C13. This is 1,3. This is not chiral carbon. So C option is incorrect, and D option is also incorrect. Two same groups on this carbon atom. So D is correct option. So this is all about the isomerism and introduction of hydrocarbon. Hopefully you understood all these questions. So if you understood, please like the video and subscribe the channel. Thank you.